Abhishek. I welcome you for this session.
Hello, am I audible to all of you?
Yes, sir, you are audible. Welcome, sir. Over to you, sir. Thank you.
I hope I am audible and visible to all of you.
Yes, sir, you are perfectly audible.
Hope my screen is visible to all of you.
Yes, sir. It is audible, sir.
Yeah, and my screen is visible to
Yes,
everyone.
sir. It is available, sir.
So can I start now?
Yes, sir. Please, sir.
So good morning to one and all present. Uh, so to the faculties of universities and I am Kumar Abhishek. I'm working as assistant professor in Department of CSE NIT Patna. So today I am here to present my views, present a talk on application of AI in software-defined network and cybersecurity on behalf of National Technology Day. So generally, my domain of work is in AI, and I'm using AI as a tool in some various fields of computer science. I will be sharing my views and work in that area. So this is the content of the presentation which I will be going through. So starting off with AI, evolution of AI, what are the application areas of the artificial intelligence, and then how a little bit of software-defined network and how AI can be used in SDN and whatever work we have done till date in this area. So artificial intelligence, we know in various ways. Okay. Uh, Generally, nowadays, many of us talk about machine learning, deep learning, natural language processing. In that, we talk about sentiment analysis and all those things. We talk about pattern recognition. Okay, so these are subset of AI. Generally, these have been born out of artificial intelligence. Basically, artificial intelligence was developed keeping in mind that the computer system having the same intelligence what we human have. Okay, so we have to program or we have to make our system smart in or system in such a way that it should have the same level of intelligence that we do in respective scenario with respective cases. Okay, so generally uh, this was the main idea. We have various sub part of AI. Generally, when we talk of artificial intelligence, we can divide it in various subdomains. One of the and the technologies that are being commonly used in this field are machine learning, deep learning, natural language processing, computer and computer vision. These are the commonly used technologies to implement the concept of artificial intelligence. So basically, my domain of work deals with NLP, ML, and DL. Basically, I started off with knowledge representation, so which is one more a core domain of artificial intelligence, where we talk about how to represent the data so that machine can extract knowledge out of it. Okay. So the basic objective behind this AI was automating. Basically, I have written 3 points: automate tasks, decision making, and predicting outcomes. Basically, decision making is the core of AI. So if we can train our computer system in such a way, it can so that it can take decision with respect to what we human do in what in the perspective scenario or in with respect to the use cases. So this is a general timeline how AI has been developed over the years. So basically, it started off with in way back in 1950s, where the first term of AI came about human intelligence, how AI should be done. But in the year 1980s, was the, I can say, this was the era where we got the concept of something we know as expert system. And in the year 2000, the whole scenario changed when we got this tool as machine learning. Okay, so this whole scenario changed with the advent of machine learning tool. And 2010 onwards, we are working towards deep learning and big data integration. So these are the evolution timeline. And currently, recently, we have been seeing a trend towards federated learning, adversarial learning, explainable AI, and edge AI. These are the new current topics of AI where the work has been started, where we talk about federated and adversarial learnings. So, with respect to the application where AI can be used, the first and the foremost is was in the healthcare domain, where we can use it for diagnosis, discovery, and robotic surgery. These are the three fields. Apart from that, we also use it in cases of diagnosis. Basically, we talk about classification over here, whether to determine something has been there or it has not been there. Okay, so diagnosis, robotic surgery, when we talk about robotic arm and all those things, and drug discovery. These are the three domain where AI has been mostly used. In diagnosis part, there has been too much work. Basically, where you might have heard of where we are going into classification, binary or multi-class classification, especially in domain of neural health, or in cases of your pneumonia or any lungs related diseases. In cases of finance, where we talk about fraud detection and algorithmic trading. Okay, these are the two domains where AI has been frequently used, where we are studying the data, where we are studying the past trends and the recent trends. Based on that, we are talking about what could be the best possible trading views, or what could be the in case of fraud detection, we are studying the past history data, and we are finding out what can be the normal behavior and what can be the abnormal behavior. In cases of manufacturing, where we can use AI for predictive maintenance. When we say of predictive maintenance, we talk about the machineries where which has been working for 24 hours and 365 days, and where the frequent monitoring is required, and how the system can work through it, and how the system needs to be maintained should be done in a computerized way. Okay, and automation nowadays, you might have seen there we work on. There has been very less human involvement in the assembly lines and all those things. So where the concept of AI has been used frequently to remove the human intervention. And transportation, in case of smart cities, transportation has been your a huge boom, where we talk about route optimization, what could be the best possible route. Okay, autonomous vehicles, where we talk about vehicles without drivers, and also uh, we talk about transportation is. I have written these two topics, but it is not related to these two topics. It can be more if we talk about smart city application, where we can talk about a smart route optimization, smart traffic optimization, smart parking system, where the concept of AI will be used to give the end user a perfect choice for using its routes or the parking space. Okay, then coming to retail sector, where we talk about your mm, buying on e-commerce website, where we are focusing on recommendation. So, what will be the best best product that would be selling on your e-commerce website. What can, and it also, AI can be also used in the demand forecasting based on the past experience or based on the past data, which particular product goes on which particular scale of the year or which month of the year. This we can do it. Okay. Also, in field of education, where we talk about intelligent tutoring system and grading automation. Basically, this talks about your cognitive traits, where the education system will be molding itself based upon the student's IQ. So what we are doing is, we based on, if a student is intelligent, for him the study material will be designed in a different way. If a student is little bit um, not so intelligent, he's a mediocre, for him the study material will be different. And if a student is very very weak, for him the study material will be a different thing. And similarly, for all these three categories, we will be having a different set of tests, and for them we will be having a different set of automation. Okay. Finally, coming to the software defined networking, SDN, which is my domain of work. Recently, I have been working in this area. So, where we are focusing on three important aspects of SDN. First one is your intelligent traffic control, then neutralizing your threat. That means we talk about dynamic threat detection. When we talk of dynamic threat detection, we are talking about real-time scenario and policy optimization. Policy optimization talks about how we will be handling the traffic and how we will be handling the data, okay, and how we will be handling the users in our network. The software-defined network is it is nothing but it is an extension to our computer network, where we are using software to control the network. So generally, when we talk of software-defined network talks about two important aspects. Okay, the whole architecture is divided into control plane and data plane. So generally, if we talk about control plane and data plane, so the control generally we are dividing software-defined network into two planes: control plane and data plane. So control plane is nothing but which will be managing the network behavior, and it will be deciding the forwarding decision. Forwarding decision means which packet needs to be forwarded. Okay, and the data plane is responsible for routing of your packets, how your packet will be routed. If we talk about the components, we have a controller, we have forwarding device, we have southbound and northbound APIs, applications, so open flow and apps and policies, these are there. And the benefits is that we this is first thing why we are moving towards software defined network is the program. First one is your programmability. Here everything can be programmed. It is highly flexible. It can be built over your legacy based computer network systems, and the control over here is centralized. We can centralize. This is we can centralize. We can control the controllers in a centralized fashion. So now, why we use why to use artificial intelligence in software defined networks? So we need network management in a dynamic manner. So, and SGN provides network management in a help, help us to manage network dynamically. Okay. And for managing network dynamically, we need to have that level of intelligence, and that is not possible without using artificial intelligence. Okay. Now, if we have to use artificial intelligence in software defined network, what can be the goal towards using AI in SDN? The first is your automated traffic routing. We are talking about your data, how data can be. routed from data plane to the other controller. It can be directly routed to the controller. It can be directly routed to the end devices. So how this traffic routing needs to be done, that can be done better with the help of AI, where we can analyze the whole traffic, and based on that traffic, we can do our routing so that there is no congestion in our network. Second, and the most important thing is, we are talking about vulnerability over here, vulnerability, anomaly, and intrusion detection. So when we have a network, there can be a legitimate user or there can be illegitimate users. So we need to see where there has been an attack or where there has been an abnormal behavior. Okay, so for that we need to analyze the traffic, and for that we need to analyze what kind of data is being used by a specific set of users. So this classification is required, which has to be done in a automated way, and for doing this classification of data and to identify anomaly, benign and or intrusion behavior, we need a tool, and AI provides us a tool to do this activity. Similarly, for real time decision making, we are talking with respect to the heart of the SDN, where we talk about the SDN controller. So SDN controller will be able to do real-time decision making if only it has a knowledge of the past data and the knowledge of the traffic that it is being facing over the period of time. Okay, and if this needs to be done at the controller, if the controller is able to understand that this data is not normal, it needs to stop that data. It should not go further ahead from control plane to the data plane. It should not mitigate to the other devices. So these all activity requires an automated technology, and AI provides a tool where we can easily do this real time decision making. We can do it in an effective way. Ease means I am talking about effectivity over here. Okay, and in a time efficient manner. And finally, and the most important thing is predictive network analytics. This is completely dependent with your flow of data in the network. What can be the network flow, and what can be the data flow in the network, and how this can go ahead. Okay. So generally, we need to analyze the traffic over here. Predictive by analyzing the traffic, we can predict what can be the network load and what can be the zone where we could be focusing on which specific data set or from which specific protocol is more towards your anomaly and intrusion. Generally, we when we talk about predictive network analytics, here we are talking about TCP and UDP flow. We need to analyze that, and based on that we will be analyzing the network, and we will be predicting what can be the future network load can be look like. Okay, so then we in this slide I am talking about application of artificial intelligence in SDN. So first one was traffic classification and prediction. Here there has been numerous work has been done in this domain, where I am talking about traffic classification and prediction. So here I have gone through various work where the researchers has used AI models for reading the traffic patterns. What when I'm talking about traffic patterns, I'm talking about the data packets, the flow of data packets. And by learning this patterns, we can target two important aspect over here. The first one is your congestion control. So if you are able to learn the traffic patterns, you will be able to avoid congestion. so that your controller is not overloaded. Also, it will help us in determining whether my system is not whether my system is experienced DDoS or not. So DDoS attacks generally happens when the intruder tries to overwhelm you by giving numerous amount of requests, a specific request. So these are, so for this we need to learn the traffic patterns, and for learning the patterns we can use AI models. When I am talking about AI models, we can use machine learning and deep learning models. There are numerous work in this domain that has been happened where they have used normal machine learning model and deep learning model uh, uh, to predict the traffic patterns. Second one is we talk about intrusion detection system in SDN, and for doing this, we need to analyze the real-time data, and in that we need to find out which one is benign and which one is malicious. Okay, so benign, I am talking about the normal data flow. So for this also we need, so generally what we need to do is we need to classify that this data flow is benign and this data flow is malicious. And for doing this also, we need AI models. Generally nowadays, we are using deep learning models for doing this. Okay, uh, as in real time system, deep learning models work well, where we get huge amount of data, and from that we need to classify it as benign and malicious data. Okay, and third, and the most the commonly third domain where AI has been used is your route optimization, routing optimization, finding the best route. We all know about in this computer network, we in the routing principles, where we talk about optimizing a route or to finding out the best route for the packet to travel or for the data flow. So generally, we need to find out the optimal path based on latency and node on every link. And for doing this, we can use AI algorithms. There has been work in this domain. AI algorithm has been used for finding out the best path based on latency and load. Okay, and then the most important thing, resource allocations. So when we talk about resource allocation, where with respect to networks, we talk about generally optimizing the bandwidth and optimizing how to optimize the bandwidth so that more amount of data can flow through it in an efficient way, and virtual network functions. Okay, so, and also we can use it in cybersecurity. Artificial intelligence can be used in cybersecurity also. First of all is for your detection of threat. When we talk of detection of threat, we talk about malware, we talk about ransomware, we talk about phishing. And how we can do it, we can do it using classification. As I told you, we need to classify data. Okay, and this classification can be done using machine learning classifiers only. Then we talk about anomaly detection. Anomaly detection means how this can be different from your normal behavior, how the pattern is being changing from the normal behavior. And then finally then we talk about security automation means if there is an attack, how we need to respond at that moment of time. That is what we talk about security automation. And then um, user behavior analytics. This is completely monitoring how we need to monitor the user. Okay, and we, based on this monitoring, we need to classify the user whether it is a benign or it is a malicious. Okay, this all things can be done using AI only. Okay, AI models are the best way to do it. Best way and the cheaper way to do it. Okay. Now, here I am talking about the case studies. This slide, I have jotted down three case studies, which is my work, which I am doing with my research scholar. Okay, which we are working presently now. Uh, Deep learning for DDoS attack detection, federated learning across SDN controller for collaborative threat intelligence, reinforcement learning for dynamic firewall rule optimization. So these are the three areas of work which we are working on it, and basically what we are doing, we are generating data. Okay, so data generation. Generally, if we have to work on SDN, just I want to share it. You need some data. See, without data, AI models cannot help you. So you need data. Either you get data somewhere, or you need to generate or your own data. Since in our case, all these scenarios are being in a real case environment, so we are generating our data. Okay, so data generation can be done using some tools. And when we talk about tools, there is one simulator, we call it as Mininet, which has been provided by MIT. Through that we are generating our SDN specific data. Okay, it is a very simple tool which you can use it, and it is open access also. Okay, so you can use it very easily. Okay, so we are using it in Linux. Okay, do not worry, if you have a Windows system, you can use it through virtual machines. You can install in your system and you can run it. Okay, so I will be discussing these case studies one by one. The first one is your deep learning model for DDoS detection. So generally, what our target was for is was to seize. Generally, this is as I said, control plane and data plane. So here we are talking about the attacks that will be working on data plane. Okay. So generally, denial of service attack. Here we talk about distributed denial of service attack. Okay, so generally, what we did is we had generated this data, DDoS data. Okay, we had generated our DDoS data, and what we have done, we have taken data of other researchers also. Okay, and then what we done did we divided this data into two parts. Okay, there was two parts. When I say I have divided, suppose I have 100 data, I have divided 50-50 like that. And that in that 50, what we did, we were doing some labeling. Labeling was to label that which can be normal data, which is not a normal pattern. Okay, and when we had this data, what we did, we tried we used some existing models. You might have heard of CNN or LSTM, convolutional neural network, and LSTM, long short term memory. Okay, so these are the deep learning models. We had used these two models for training on flow level data. Whatever data was coming to the data plane, we had given these two models these data and gave them a proper training. Okay, on how the data can be, what can be the normal data, what can be the DDoS data. Okay, and after that we tested it in a real time environment. In a real time environment, we so what we did, we divided 60% of the data for training the models, and 30% 40% data for testing. Okay, so for the entire data, what we did, we made a group of 60 and 40. So for 60% of data was used for training the models, CNN and LSTM, when they were able to identify that, okay, from in this data, this was the normal data and this was a DDoS attack, then we gave them the, then we tested it. Okay, so then we gave the next 40% of the data to that models, and we saw that they were able to uh, learn the pattern and accurately identify what can be the DDoS pattern. Okay, and then when this was completed, training testing, then we gave the real time data to this models, and we were able to see that the models was easily able to identify what were the patterns which were leading to the distributed denial of service. Okay, so this was a very effective thing what we achieved, and what we see that the decision making was highly automated and there was no administrator involved. Okay, so what we did, we run this code and we developed this model, and this Python script was incorporated in the controller in the data plane, and the controller with this AI model program, he was easily able to identify the data which was benign and which was denial of service attack. Okay, so this we tested and we found that this was a really good thing that we were able to do without manually changing the controller. Okay, without when I say manual rule setting, I am talking about going sitting to the controller and writing the code at the controller. But what we did, we only incorporated this AI models at the controller by using a normal script. Okay, Python script, you can use it, and we installed it at all the controllers, and then we were able to find out, oh, this that the controller was easily able to classify the traffic, and it was easily able to identify which traffic was a denial of service pattern attack. So this was our case study one. Then was where we have used federated learning. Federated learning is a new topic in AI, which talks about how we can study the models and how we can use it properly for learning. For generally this from data plane we are moving towards controller. So now we have been talking. The previous attack was related to previous case study was related to your data plane. This we are talking about your SDN controllers. Okay, so here federated learning, what we tried to do is we had generated data. Okay, various datas of various entities, and here we talked about here we talked about federated learning. Okay, so this was what we did. Federated learning means where here we I'll just wrap it up. Here what we did, generally we developed we generated data of various entities and we combined. So what we did, first we trained the model on the various entity data separately, and then we combined it, and then we trained the data. That is what is federated learning, where we are collaborative. We are collaborating the various data and then we are learning it. Okay, so here also we were able to the main target was to for your privacy. Okay, here we were focusing on data privacy. Okay, and this was also done in a very efficient manner, and we were able to achieve nice results in real time. And third scenario was your reinforcement learning for firewall optimization. So tuning of firewall rules based on network behavior. This, so for example, if the traffic, so if there is a threat based traffic, the firewall rules should change automatically. Okay, this also we have done it. Okay, so this was my third case study where we were working on the firewall optimization directly. So this is the benefits of AI in SDN: faster detection and response. Challenges: these are my challenges: data privacy, model interpretability, scalability of a large scale network, need for standardization and robust data set. This is my conclusion. AI is revolutionizing. So network management and security. AI has been used very nicely in this domain. So what we need to do, we need to integrate with SDN, which will offer more proactive solutions. And what we can do is now we can think of federated and explainable AI models in SDN. Okay. So thank you. If you have any questions, you can ask me.
Sir, good morning, sir.
Good morning.
Sir, on behalf of the City University, I just want to thank you. You have given your valuable time, sir, in your busy schedule, sir. And your talk is very inspirable for us, sir. And thank you very much, sir. You have given this talk also, sir.
Thank you. So we can conclude now.
Yes, sir. Thank you, sir.
Thank you.
Thank you
Thank
very
you.
much.